Thank you everyone for joining today. What an exciting segment of the satellite industry to discuss when we're talking about Smallsat. They have been not only the most dynamic segment of the industry with regard to growth rates, innovation, and a business model, but also they have been quite exciting in terms of events. Can you believe that during the last 9 months, more Smallsat were launched, approximately 800, than in the whole last year, which was already a record-breaking year with almost 385 small sats. And small sats are definitely experiencing significant changes, and we will go through this quick webinar to present how do we see the small sat industry going forward in the next 10 years, but also discussing with you and happy to take your question at the end of this webinar. Smallsats are definitely leaving the infancy stage, or let's call it the Stone Age, entering a second phase in which at Euroconsult we anticipate more than 10,000 smallsats, so satellites as we define them below 500 kilograms, to be launched over the next 10 years. We definitely see a significant expansion in terms of number of satellites, with a fivefold increase over the next 10 years. And this increase will be fueled primarily by the rollout of multiple constellations, which we anticipate to account for 85% of the smallsat demand, mainly for commercial operators. And within those operators, two North American mega constellations, namely SpaceX Starlink and Amazon Kuiper, alone will account for half of the smallsat being launched and 80% of the mass being launched. So significant changes in the way we see the market. And looking into the detail and the variation, we assume that over the next 10 years, we will reach a yearly average of 1,000 smallsat being launched, with, of course, variation expected from year to year because of constellation, which are which demand is by nature cyclical, and which foster strong variation due to their first need for demonstration, then deployment, then operational capability, then replacement, or in the best cases, expansion. And on the other hand, single satellite missions are still there and growing, but will remain more limited and almost stable. Speaking of mass increase, we are talking about small sats here, but small sats are getting heavier. And despite overall miniaturization effort, higher performances, when you have to deliver and improve your capex efficiency, you will likely go for a little bit more in terms of mass if you can have better performances. And these gaps between mass and number of satellites is fairly shown when we are talking about the Cubesat form factor. Looking into the below 10 kilogram demand, for example, we anticipate that they will account for 23% of the units in number, but only 1% of the mass being launched. And those variations can be found also in value, and we'll go a little bit more into the detail over the next slide. In terms of manufacturing and launch revenue, we anticipate both growth, but not at the same speeds with regard to the differences between system costs on one hand and cost reduction efforts, which are not evenly distributed. Let's have a look to the structural demand and supply drivers. Smallsat, they cover a wide range of applications, with distribution is also changing. Telecommunication, namely for broadband, is expected to have the strongest growth in terms of number of satellites to be launched, and with almost 5,700 smallsat being launched, again mainly for Kuiper and Starlink. We also have Earth observation, which is expected to grow around 1,500. But in terms of market share, which will decrease because, again, of the weight of telecommunication. Technology goes down to the third position, but demand for in-orbit validation, demonstration, and payload will remain steady over the next years. We are not talking today about other applications, such as information for IoT, low data rate connectivity, or science and exploration and security, where a lot of things that are happening, but that would be the topic of another webinar. And these changes in application are also reflected in the operator distribution, so the type of people which actually operate them. And commercial users will overtake government as the leading segment of the demand, accounting for 17 billion in market value for both manufacturing and launch, as a result of the rollout of constellations of all sizes, ranging from 10-ish assets up to hundreds or thousands. Civil government will remain the second larger operator and are transitioning, which is very interesting, from demonstration through Smallsat to operational mission. And we have seen successful demonstration for very high demanding use cases, such as exploration around Mars as a piggyback, and now we have NASA and other space agencies endorsing Smallsat for operational mission. Defense users are there too. They're also growing compared to the last decade. They have triggered Smallsat in a way a few years ago that which was driven by responsiveness, and now we see them endorsing Smallsat for operational capability, leveraging on the resiliency of having multiple Smallsat, but also leveraging on their lower cost compared to heavier system. Looking to who and whom and how Smallsat will be manufactured, it's interesting to see that 2/3 of the units will be manufactured in-house. Smallsat industry likes vertical integration when we are talking about mass production, enabling economy of scale, faster innovation, and also better control of your supply chain. And this process becomes relevant when you have continuous needs for satellites, namely limited lifetime and need for significant replacement. In front of this, there are a lot of Smallsat companies, either pure player or legacy satellite integrator, which are diversifying to Smallsats. And in front of these many players and many manufacturing capabilities, sustainability of this segment is in question. Just to give you an idea, over the last 10 years, only 16 manufacturers have built 50% of the Smallsats. And we see more and more people joining the party today, and there will not be room for everyone in this area. Let's go to launch, where we see also interesting things. And now we wanted to show you the distribution of demand and supply by country to emphasize that launch is a global market, and there is an unbalanced distribution between the demand on one hand and the supply, leading to a global marketplace where Smallsat are finding their way to reach orbit. We only have 11 countries which own launch capability, and on the other hand, we had 70 countries which were looking to a launch solution. And it's not because you have your own launch solution in your own country that this solution is actually meeting Smallsat needs. Because of the performance, because of the pricing, domestic supply may not be compatible and or available, and it's explaining why, for example, in Western countries, Smallsat operators have been looking for launch abroad, such as in India and Russia. We have seen, of course, over the last 5 years, numerous Smallsat projects of Smallsat launcher being under development. As of today, only one, namely Rocket Lab, is operational. And when you see the gap from the US or Western countries going abroad, this is really why micro launchers are being developed and are looking to retain this demand domestically by providing responsive access to space rather than going abroad on a rideshare. And speaking of this emerging application, rideshare have helped to reduce the launch bottleneck in a way that launch have been optimized, providing more launch opportunities to either rideshare or piggyback on board to the ISS or on heavier launchers. Let's talk about the impact of COVID-19, and we have a quick poll for you to answer what is your main concern about the Smallsat market in the context of COVID-19 in the coming years. I'm really curious about your answer here. So let's talk about COVID-19. We see the impact of COVID-19 in 4 ways. First of all, manufacturing delays, just because Smallsat manufacturer had to stop or to slow down their production facility to comply with government regulation. And most of those companies, they fear financial penalties due to delays. In some cases, we have seen that for government program, governments were willing to reduce or to delete these fines to make sure that a company will not be liable for delays in this very specific context. Access to space was also impacted with shutdown of spaceports, not in every at every launch site, but some campaigns have been fairly impacted. Demonstration and maiden flights of launcher, of course, also have been delayed. While the launch bottleneck of COVID-19 is reducing, the industry has still to cope and to launch and to resume before the COVID-19 impact. Of course, in a context of uncertainty, of commercial withdrawal, pivoting to government is an obvious move, I would say, in the satellite industry, and Smallsats are no stranger to this. To avoid bankruptcy or foreign takeover, Smallsat company have been calling their government either for emergency support or pivoting to government as a most established, reliable customer compared to new markets on the commercial one, which have yet to be unlocked by Smallsat solution. The last one impact is investors. Given that several companies have experienced Chapter 11 bankruptcy, we can expect investors to have lower willingness to invest in bold projects, to be a closer look to return on investment and business plan. Whereas we have seen, I would say, exotic value proposition or large investment. We think that this is going down because of investor being more careful with investment. And OneWeb crash and failure to secure enough funding and going therefore to Chapter 11 is a good reminder that even the most advanced projects, the most well-funded, are still looking are still exposed to risk. Of course, with this situation, we have updated our model and our forecasts, and we anticipate early stage commercial new entrants to actually have facing more difficult fundraising from the investor and launching a little bit less. That being said, we have removed more new entrants. And on the other hand, we expect legacy player, well-advanced player, to actually keep a steady speed. Just keep in mind that in 1.5 years, SpaceX became the largest owner of assets in orbit, despite the pandemic, launching through the pandemic, and now operating more than 600 Smallsats. Let's have a look to and focus on mega constellation. It has been a segment which has been a subject for a long time to discussion about market realization and discussion between revolution or investment bubble. Mega constellation are definitely here today because of the decreasing cost of Smallsat. Barrier to entries are a little bit lower than they used to be in the previous generation, and have attracted new players that we have to assess in a different way. The way we do it at Euroconsult, we have scouted and reviewed more than 270 projects, and out of this, we have made a selection regarding to their credibility of investment, technical maturity, and commercial credibility, providing maturity assessment on those constellation, in which large LEO projects have the lower ranking. and which is quite a paradox because this segment is one of the most advanced. Again, SpaceX and Kuiper are fairly funded. SpaceX again is the largest operator of assets in orbit, but they still face significant challenges for them, such as securing landing rights and distribution partner to actually distribute your global coverage. User terminal availability and affordability is still a question which has not been answered yet. And in this context, they will still need to demonstrate to the investor that they are able to deliver on time and on budget. Of course, they are facing very different situations. When we are talking about Kuiper for Amazon, we can fairly say that Amazon profits are sufficient to fund the constellation, whereas SpaceX is actually still looking for funding and raising equity to finance either Starlink or Starship. And the recent move and rush that we have experienced in the last few months regarding filings, protests, and battle in courts or launches are actually driven by a very US-specific context in which the FCC has enacted a rural broadband opportunity to reduce the digital divide, which is funded up to $16 billion, in which the telecom industry is, of course, looking to secure some fundings, in which the satellite industry wants its lion's share, in which emerging projects such as LEO constellation are also looking to eat a bit of it. When we look into the specificity of the mega constellation, we have to emphasize that there is a huge differences between the number of assets they will operate and the value. Again, in a number, they will account for 50% of the Smallsat being launched, but in value, they will only account for 17% because of the economy of scale adoption that we have explained. And each has different strategy, either the business to consumer, either to wholesale reseller to telcos, or even to answer its own needs, as we assume Kuiper to be designed for. And this vertical integration model is not limited to the satellite manufacturing only, but is also driven, is also impacting on the launch side. Both of them will operate partially reusable launcher, which enables them to launch at marginal cost, providing them significant advantages compared to competition. And for example, just benchmarking the cost of the assets, OneWeb satellites, despite being lighter, are expected to cost 2 to 3 times to launch more than Starlink and Kuiper, which are actually heavier than OneWeb satellites. In this context of mega constellation and connectivity rush, Smallsat are not alone. There is also a non-Smallsat constellation, which are joining the party. Namely O3b mPOWER, Telesats, and few other projects that we are not discussing today, but we are there and at making this competition and the Smallsat market evolution very, very exciting. I think we're almost on time, and we can take some questions from the audience. Just looking to the result of the poll, it's interesting to see that the audience, well, at 57% think that the biggest risk for the Smallsat industry in the coming years is actually the investor risk assessment and funding availability. Okay, so definitely more on the business side. We'll see in the coming years, and in terms of fundraising, at the end of the year, if Smallsat have been able to still secure the same amount of funding or even growing compared to last year, or if the trend is decreasing. But that's an interesting result.
Thank you, Maxime, for that. And as mentioned earlier, now is the time to submit your questions if you have not done so already. So let me just kind of kickstart this Q&A with the first question. Maxime, you've mentioned at the beginning that we've seen more small sats being launched this year than ever before. Is it counterproductive to anticipate so many more launches in this time of economic crisis?
As I mentioned, the space sector is not immune to the international economic context. We have experienced ripple effect from the 2008 economic crisis, and we experienced a slowdown in those years. But when we went down to the project by project of constellation during our assessment, we believe that actually there is still room for growth. But the growth will kill the younger projects, and the most established one will actually launch more. So adding the satellite after constellation, we ended up having more satellites than in the last year forecast, despite being in economic crisis. But this is because of a larger player launching more satellites, and as I said in the previous slide, also concentrating on more risk. But at the end of the day, yes, it could be counterintuitive, but we anticipate more satellites to be launched.
Within our report, we also have considered also a global perspective, and one of our attendees is also asking whether we can share more information on what is the case of the African Smallsat market and the Smallsat industry. If you have any insights to share on that.
That's you mean on the Smallsat market or specific for Africa? Not sure to follow.
What is the case of the African Smallsat and the Smallsat industry in Africa? Perhaps
So,
a few insights on numbers and what are the growth perspectives for Africa?
Remembering how the origin of the satellite operator distribution in Africa, we mainly have small projects either by university or space agencies to demonstrate that there is a capability to manufacture and operate Smallsat, and of course they are going to Smallsat because of the affordability of the system. And this is largely part of government effort to enact science policies and kickstart an industry. In few cases, as it has been the case for heavier satellites, this is part of a technology transfer program where people will actually help and support either another government as part of a diplomatic effort, or an industry player will help to establish not only the manufacturing capability, but also the service capability of and developing application. And this is why it's very interesting to see the African segment. But in terms of numbers, it's still fairly limited, smaller compared to other regions of the world.
Another question, thank you for that, Maxime. Another question coming from one of our attendees is, in your view, which part of the Smallsat market are you expecting to deliver the highest growth in the next 3 to 5 years?
If we are talking about numbers of Smallsats, this is definitely broadband. This will be a little bit different and a little bit smaller in terms of value, because again, such system exists, mega constellation exists because of their lower cost compared to other applications. And if we are talking about overall revenue and results, Earth observation should not be ignored. We have a lot of things happening, and because it started a little bit earlier than mega broadband constellation, we expect results to coming a bit sooner than this one. So, but building services and delivering interesting use case and added value to the right user will be key to demonstrate this success.
Thank you for that, Maxime. Another question that is coming through quite interesting. So what is your view on small GEO satellites perspectives as an alternative to NGSO?
So thanks to miniaturization, it's now possible to deliver interesting throughput from GEO and to launch an asset which is in the hundreds range of kilogram. We have some players developing such system either to as placeholder for spectrum or to provide local services to a given region or state. This is interesting in a way that it enables people to deliver capacity in an incremental way to a very specific area where people actually need the capacity compared to a global coverage where you are covering also oceans, despite maybe not having customer there. So it has yet to be demonstrated that it actually flies and worth it, but the value proposition is very interesting, and some operators have already committed to that type of asset. So we'll see in the next few years if in addition of big birds on the geo arc, we see other small geo CubeSats. We also anticipate other Smallsat in geo for other purposes, such as security. But we'll see in the coming years, and it's something which will likely grow.
And you've mentioned in your presentation that Smallsats are also getting heavier. One question is concerning this, and what is the future of Cubesats within this context in which we see an increase in average mass of the satellites launched?
Smallsats, and in particular Cubesats, are getting bigger. Currently, we see the range between around 15 kilograms. Because of the interest of carrying larger payloads, propulsion, and having a significant supply available and in the CubeSat form factor. But at some point, it becomes maybe less relevant to use the restriction and the constraint of the CubeSat form factor. And it may be more relevant to use a very small platform which enable a very customized instruments. So CubeSat are also getting heavier, but at some point the threshold will switch to smaller regular platform, I would say.
Thank you for that. Another question, and I'll do my best to translate this in some language. So in our perspective, what is your estimate in terms of percentage of geo revenues lost to LEO systems once the constellations are deployed? Or will LEO address unmatched requirements not yet served by GEOs?
That's a very complex question. We have specific report, and I have colleagues which are by far more educated on these topics. But there is definitely a room for LEO in broadband regarding low latency connectivity for some use cases. On the other hand, GEO will likely remain an anchor assets for either broadband on very specific use cases because of its efficiency, because of its coverage, and because of its need for a less sophisticated ground segment. And of course, broadcast will never switch from GEO to LEO. But on this very specific topic, shoot me an email and we can discuss this more into the details.
Thank you for that, Maxime. Another question, and this is a bit concerning also the ground segment, is whether we have taken into account the ground segment as part of the constellation business models that we've analyzed, and whether you can share some thoughts on how reliable and mature is the ground segment part of the business model, and what would be potentially risks or future viability concerns for future projects.
Yeah, it's definitely that we had a look to. It's a good thing if you have a constellation in orbit. It's a nice problem to have. There is another one which is having affordable terminal to distribute and makes your capacity available to your users. So we still see a bottleneck here in the coming years in terms of pricing. Those flat panel antenna are not that cheap, and if we want to deliver and to reduce the digital divide, we will need rigorized and low-cost system. So this is really something that we are looking at. We had the chance to discuss one alternative to a large network of ground segment, which is interlinked satellite, which is also an interesting parameter which is also discussed in the small satellite report. But yeah, when we are doing our forecast, we not only have a look to the satellite, but we also have a look to the ground segment, and we have also a specific report on this at Euroconsult addressing the issue.
It's true. Do check our website for all of our reports. Indeed, we have quite a few of them. And perhaps just like to keep an eye on the time and just taking maximum 2 more questions. Maxime, actually, I wanted to, because this is not the first edition of our Smallsats report. You've been analyzing the market for quite some time now, and I wanted to have your take on, what are your lessons learned from looking at the market and the market forecasts, and also whether you can give some insights on the sustainability of the business model of the mega constellations that we're seeing.
So to answer the first part of your question, Smallsats are definitely very hard to forecast and harder to forecast than heavier satellites. Whether Smallsats are launched in constellations or in large batch, or launched or aggregated on rideshare, meaning that in both ways, we are talking about volumes where there is a lot of elasticity and concentration, and making room for error in our forecast. So to mitigate this, we do every year a reality check. We also have developed internal tools where we assess the maturity of our constellation, and we look really into the detail about the availability and the credibility of the system, regardless of the operator announcement and schedule. We do not believe the schedule of people. We do our own assumption, and in doing this, we have been able to do reality checks in the past edition, assessing our margin of error from one edition to another, which sometimes could be just challenged by few percent because of a launch delay, or to the contrary, a launch which was not expected. But this is something that we do transparently to identify in which segment we were good and wrong. But with the time flying, we are definitely getting better and improving the accuracy and providing more insight about how the Smallsat market could go in the coming years.
Thank you, Maxine. And perhaps a last question from my side. What do you believe are the factors involved when it comes to the make-buy decision that is driving the service provider to become eventually and shift to become a satellite manufacturer?
So in-house manufacturing is really driven by the willingness of operator to either outsourcing their production and focusing on their business model and value proposition. So delivering a given capacity or given service to user, or keeping control on your value chain, on your assets. And sometimes it's also about keeping what you have developed secret for yourself. You want to have exclusivity of your technology. So most of the time we see people saying that it will be cheaper for them to manufacture by themselves. I would say that have a look to what's been going on to the supply and the significant effort that the manufacturers and subsystem companies have been doing to provide a reliable, cheap system. And then we can see that there is no single answer, and in every cases you have to look into the cost to make your decision between the buying or outsourcing, or doing it in-house. Sorry.